Hey everybody, this is Larry. This is day 20th or Jan 20th. I'm trying to do more. Basically, we've done the problem, or I've done the problem that the daily promise, and I'm trying to get my money's worth by picking one random problem I haven't done before. And today's random problem is 998 maximum binary tree 2. It's a medium problem. And apparently that's a lot of downvotes, so we'll see how this goes. A maximum tree is a tree where every node has a value greater than any other node in the subtree. Isn't that just a heap? That's a heap. I mean, I guess a heap is is it complete, or I forget the term for it. But a heap, it does fit this description, though it may not be the general version of this. But in any case, you're given the root of a maximum binary tree and an integer value, just as the previous. This is the previous form. Should I do a previous form first? All right, I guess I should do the previous one first. I don't know. All right, let's just do this one first, and then I'll make a second video doing this one maybe. All right, let's just do this one first. So if you're watching this, you may be confused about the title bit and how I get here, but it makes sense, right? So okay. Maximum create a node whose value is maximum. Okay, yeah. Recursively build the subway. Okay, so just repeatedly get the max, right? So what is the idea? Well, what is the build the left subtree? What? Oh, so basically, if you're given, but see, that's the part that I don't think. Oh, subway prefix. Okay, I see. I didn't really read this correctly. All the numbers are unique. All right. I mean, this is pretty straightforward. What does this remind me of? I mean, I guess this is just like I mean, it's not quite the same, but it is the same idea with like sorting structures, right? But yeah, but it's not that bad. So the way that we can think about it, so we'll just have a construction thing, and then here we want the left, right, and yeah, left, right. What is that? It? Yeah, I guess that's it, right? And basically, what this does is recursively, construct the current node. Yeah, right. And here, basically, we have, and I think you can actually. I'll talk about the complexity later, but I hope that it is not n. Well, okay, it is going to be n squared, but n squared is fast enough. Is this not n squared? No, that's I don't know. Sorry, I'm jumping around a little bit, but yeah, this is going to be n squared in the worst case. But you can actually do it in much faster if you're really slick about it, and you can do this in. You can do this in linear time, but that's a ridiculous solution. But in any case, okay. But yeah, and I'll explain why in a little bit, or how in a little bit. But yeah, so then here we have the max value is equal to just max from num sub left to right. I think right but plus 1 to make it inclusive, because I like it to be inclusive here. I like my functions to be inclusive. I don't know. It doesn't have to be. It's just that's the way I like it, right? So then now, yeah, and then now we have nums dot index of this number. We probably could actually do this like much cleaner. Just add some lazy. I'm just lazy. Okay, fine. No. Yeah, okay. Let's just do it in a non-lazy way, Larry. So okay, so max is equal to num sub left. Max index is equal to left. I guess max index is fine, right? And then now we have for I in range from left plus 1 to right plus 1, because we want the right inclusive. If num sub I is greater than num sub max index, then max sub index is equal to I. Something like that, right? So now we have the maximum index. Then now we can construct left max index minus 1. So this is going to be the left. So this is the left node. Oh, that actually overshadows the variable. So left node, right? Right node is equal to construct right max index plus 1, right? And yeah, And then now we can return a new node, a tree node, where the value is equal to the max. So num sub max index, left node, right? And of course, we actually have to change the base case scenario a little bit, which is that if left is greater than right, then we return none. I think that should be good, right? And then now we just have to return construct 0 and then n, right? Or n minus 1. And then we'll give it a submit. Hopefully this is fast enough and it looks Gucci and we're good. But yeah, so a couple of things. I mean, I did this pretty quickly, but hopefully everything kind of follows. But we just recursively look at the sub array, which is what they tell you, the prefix and the suffix. And we have to get the index for the maximum index, right? So what's the complexity here? Well, it turns out that if you have like a linked list thing kind of similar to this, and the max value is the last item, say, then basically every node is going to only take out one node, and so then this range thing is going to make it n squared, because the first time is going to take n operation, then n minus 1 operation, n minus 2, all the way to 1, and then of course that's going to be n squared over 2 some ish, and which is n squared, right? So this is going to be n squared, but you can actually reduce this by using some sort of RMQ solution. RMQ stands for range, I guess range min query is the common one, but obviously in this problem you can convert it to max, and because the list of numbers is constant, or it's static, you can pre-process it to answer queries. You may even be able to do better than that, to be honest, but like with RMQ directly. But in any case, even if you just do that, you're able to do this in all of one time, and therefore you're able to like instead of having a loop, you're able to get the maximum index in all of one. So that means that every construction of node is going to take all of one, so that's going to make it linear time, linear space. That's pretty much it. I am gonna if you're looking for this video, I don't know if you are, since this is ORNG anyway, I will have a different video right after this. But yeah, that's all I have for this one. Hopefully it didn't go too fast. Let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see you in the next video, and I'll see you later. Bye bye.